Let's see how to use influences, a component that we haven't used yet. In the Weight Manager, I'm going to disable the initial weights. With this, all vertices will start at 0 weights. I'm going to create an add step, which adds weights on top of the current weights. I'm using it for the spine. Let's rename it and create a standard selector. We can be generous with the vertex selection because the influence itself will determine the affected vertices. Let's create a line influence. I'm going to move it to the first spine bone. This influence comes with a line end node, which specifies the end of the influence. Assign the bone name in the influence, and the selector and the influence to the step. Add a normalized step as always. Let's try to export. As we can see, we got an error. Even with the normalized step, if there are vertices with 0 weights, they will stay the same. There should be some weight to be able to normalize it. We have values at 0 because we unchecked the initial weights. We can use a fill step to fill all values with some weight. I'll assign a selector for all vertices and set the bone name to pelvis, for example. Export it. Import. This is the result of a line influence. It spreads values across a line direction and position. Let's create a different selector to avoid the influence in the arms. Let's check the result. I'm going to move the line influence and the line end a little bit. Now I'm going to duplicate it to do the exact same thing for the second spine bone. We can edit this curve gradient to specify the weight gradient that is generated. Let's export it to Blender. We could repeat this process for each bone of the spine. The fill step that we used could leave us with some pelvis weights on the spine. We could use a remove step to remove those weights, and then another normalized step. Now we are going to weigh the head to a point influence. First, create a replace adapt step. This is a combination of the replace step and the adapt step. The replace step substitutes the current weight of a bone for a different one, and the adapt step performs a normalization, but keeping the weight of a bone the same, while changing the others. Let's create a standard selector for the head. Now create a point influence. This calculates a weight depending on how close or how far is the vertex to the point influence. I'll set a max distance of 0.25, assign the bone name, and assign the selector and the influence to the step. Export it. This is the result. It's not good enough, but we can change the result dramatically by just adjusting the gradient curve. If you are using this curve elsewhere and you want to change it only in this instance, remember to make it unique. This change will keep the closest vertices with a higher influence. Let's check the result again. Much better. As you can see, there are a lot of steps, selectors, and influence. You can experiment with them to create a lot of different results.